the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand open arms, this is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Good evening, everyone. Okay, let's see if it actually works. Yes, I can see that the microphone is at least receiving, so this should work. Again, hello everyone. Yes, I can hear myself on YouTube. Perfect. Today's topic will be CHIP-8. CHIP-8 is actually an really old school VM, a super simple VM that I'm going to implement, and is going to be basically somewhat of an intro to the requested topic of how do you approach reverse engineering a VM and how do you actually use VMs in terms of anti-reverse engineering. Well, to actually talk about these things, I decided to do an introductory live stream where I will try to implement a virtual machine, a simple one, a really simple one, and tell you, well, so you can actually see how it works, what's the idea behind implementing it, and what things you have to take into consideration. Let's see how it goes. Today's moderator is going to be Foxtrot Charlie. Here is his nickname. If you have any questions to me, then on YouTube chat, just ping him and he will let me know. If you're on IRC, you can actually use !Q and then write your question. It will be sent to our moderating channel, list basically, and we will see it. Well, Foxtrot will see it, and I will then get it. Perfect. Just to let you know, Mormos is going to stream after my stream. He might be a couple of minutes late, but he will be there, and he has some really interesting topics today, so check it out. On my info screen, which is going to be presented as usual with the mission, yes, there is a mission today, at the end of my stream there is a link to his channel as well. Perfect. So let's get going. Okay, first of all, we need to basically visit... sorry, one more thing. Let me know how you can hear me, because I actually did tweak the microphone a little, so I guess it should be a little better than it was like 2 weeks ago. Yeah, just let me know. Perfect. Now Wikipedia, let's see what this CHIP-8 thing actually is. So CHIP-8 is an interpreted programming language developed by Joseph Weisbecker. And I guess it looks like something, well, basically like a VM of a computer which has a graphical mode. So a really simple one, well, this is basically, you know, Pong. You have only like really large pixels. I have no idea what the resolution is, but it's like 100 for like 50 or something. The pixels are really huge, and they can have only 2 colors, which are black and white. And yes, so this is what we are going to be implementing. And it seems that it's a really old one. A really, really old one. It's older than me, if you can imagine such a thing. I guess you can, it's easy to imagine. I'm not that old. Perfect. So, first let's read what does the virtual machine what does it emulate, what in terms of a hardware, right? So it has memory, and it has 4 kilobytes of memory. Do I have actually, wait, yes, I do have, zooming. 4 kilobytes of memory, that's not a lot. It's really not a lot. I mean, my screen buffer, which is used to just display what you see on the screen right now, is like 2 megabytes, maybe 4 megabytes, so 4 kilobytes is nothing. And then, okay, the interpreter occupies like the first bytes of memory, and for this reason most program written... Okay, so yeah, so actually you cannot even use the all 4 kilobytes, just like 3.5 kilobyte. Then there are some reserved addresses at the top of the memory, which are used to display refresh. We will get to what is that later. Currently I don't know either. And then some other, which is a call stack basically. So it's quite... no, this is, I guess the whole stack is actually only 96 bytes. So it's a really, really simple and like low-end virtual machine in our standards. Probably in the 70s that was pretty good. Okay, in modern implementations, the interpreter, blah blah blah, there is no need. It's common to store font data there. Okay. Now registers. It has registers, so the CPU has some registers, and it has 16 8-bit registers named from V0 to VF, which I guess is like hexadecimals here. Usually, as you know, in assembly we probably use like it would be V15, not VF, but okay, whatever works. VF register is double as a flag for some instructions, so yeah, like using registers for a couple of things is pretty normal. We do it on x86 as well, as you know. So yeah, so basically don't do weird stuff on that register. There's an additional address register which is named I. It's 16-bit wide because I guess like you cannot address 4 kilobytes of memory just having 8-bit registers, but would only give you 256 addresses and you need more, so that's why you need a larger register. That being said, this amount of memory is enough to have like 12 bits, but I guess they had 4 spare bits, so that's why it's 16 bits. And is used with several opcodes, blah blah blah. Okay, so this is quite normal to actually have if most of your registers are only 8 bits, then it's normal to have like a larger register to do basically memory mapping and, well, not really memory mapping, memory addressing in this case. The stack, yes, there is a stack, and I guess you don't, so normally commonly in modern applications, the stack is used for local variables, it's used for the arguments, and the stack, we say it's not large, but it's not large means in the like kernel drivers it might mean 64 kilobytes, and 64 kilobytes is still larger than this. So I guess here, since you know your program basically owns the whole space, the whole RAM, the whole 4 kilobytes, you use differently. You use probably mostly globals and not really like global variables and not local variables. Okay, then it has timers. This is going to be fun implementing 2 timers. The timers count down at 60 Hertz, which basically means that they are like each timer might have a register, and the register might have some value, and 60 times per second the value is being decreased. So it has a delay timer, and when it reaches 0, usually something happens. So, well, nothing must, like, or something doesn't happen. So it's like this: either an interrupt is fired, or the application, the CPU actually has, or the programmer actually has another way to check if it did reach 0. For example, checking what's the state of the timer's register currently at this moment. 60 Hertz is not a lot. In modern PCs, you have usually at least 2 timers. There is the programmable interval timer, which is, I think, about 60 kilohertz, so that's way faster. And then there is the HPAT, which is high performance event timer, which is, I don't know, like a couple of megahertz, but I might be lying here, but it is something like way larger. So this is quite a small and a slow timer in, well, for our considerations, which makes it easier to actually correctly emulate, because, you know, if they would say here that the timer is like 10 megahertz or like 1 gigahertz, then we might have real problem emulating it to be precise, because 1 gigahertz would mean that basically every instruction, every assembly instruction, we would have to change it, and there would be some problems with synchronization and so on. So yeah, but 60 Hertz should be fine. We should be able to emulate it. There's also a sound timer. The timer is used for sound effects. I wonder what this means. Sound is probably going to be the last thing I plan to implement, so I'm probably not going to even bother. Let's see how it goes. The input is done on a hex keyboard. A hex keyboard, that's a interesting thing. It's basically, I guess, like a keypad, but going up to 15. And some keys are used as arrow keys. So is 8 actually up or is it down? Because if you look at your keyboard, right, and there's the keypad, then 8 is usually up, but the keypad could also be in the reverse direction. So you might have 0 at the bottom, but you might also have it on the top. So 8 might mean it's up, or it might mean it's down. I don't know, though. Yeah, it changes things, so we might have to tweak it when we find out. There are some opcodes in the CPU which actually detect this. Okay, we'll get to this later. Graphics and sound, which is another part which is, I guess, solves the riddle of what was the resolution. So the resolution was 64 to 32 pixels, not a lot. And color is monochrome. Obviously, it's either black or white. Though it doesn't have, it doesn't have to be black and white. It can be anything, but I guess black and white are the default choices. Graphics is drawn by sprites. This is quite interesting because, yeah, usually in VMs or like even older machines, so no, it's complicated, but okay. Usually you have a frame buffer and you address a specific point, like a pixel, and you light it or like turn it off. But when drawing in sprites, that means that there's probably some register which you have to set, and then you have another set of registers which basically you say where you want to place the sprite, and then suddenly 8 pixels appear there, or appear there using some Boolean logic, meaning that like for example do an OR. If a pixel is already lit there, then and your pixel that you're trying to draw is black, then still respect the lit pixel and treat black as transparent, for example. So I don't know how it is here, but we'll get to it. Okay, so the sprites are 8 pixel wide and maybe from 1 to 15 pixel in height. I'm quite interested how is it actually implemented. I guess we'll get to it later. Sprite pixels that are set flip the color of the corresponding pixel. So this is an XOR operation actually. So yeah, it's not drawing directly, it's like XORing what you have on the screen. XORing as an exclusive OR, obviously, while unset the pixel does nothing. So yeah, that's an XOR. That's a description of an XOR. The carry flag in this VF register, which was mentioned above, is set to 1 if any screen pixels are flipped from the unset to unset. Okay, right. This is used for collision detection. That's quite smart. As previously described, a beeping sound is played when the value of sound timer is non-zero. So and I guess this is related to what HonoraryBot is saying here, that the sound is probably something like pit wired to the beeper. I guess, yeah, I guess I was thinking like what kind of sound do we expect? Is it like only either there is a beep or there is no beep, or can you actually somehow set the frequency of a beep? But it seems there is only one beep frequency, so yeah, if the timer is set to non-zero, the sound timer, then you should play the beep value, and it should be beeping constantly until the timer reaches 0, where it decrements every 1/60th of a second. So that's a good remark. Okay, and here are the opcodes. It has 35 opcodes, which is way less than x86, so that's easy to implement, and it's actually like 4.5 times more than BrainFuck has, right? BrainFuck being another common VM which people implement. The important part for us is how to decode it, and this is very important information for us. It's each opcode is 2 bytes long, which is quite funny because that means we probably need 2 opcodes to fill the I register, which is the address register. But that's also how it's done on ARM, so yeah, no surprise here. And it's set to big endian, which means that if you have, I guess everyone knows what is it, but just for new people, if you have 2 bytes, right, and our opcodes are 2 bytes, then for big endian, when actually reading them, this is the top byte and this is the bottom byte. So when you're putting, like for example, this is 1122, so when putting this together, you actually get OX1122, where normally on x86 we have little endian, which means they would be the other way around, as in sorry, that was 1122. Yeah, the other way around, which means it's actually would be first the bottom byte and then the top byte. So on x86, usually the encoding is like this, or the decoding actually. But this is big endian, we have to take it into consideration. And there's a table, and each opcode seems to be actually encoded in. So yeah, this is going to be the first interesting question. Is there any smart way to do the decoding, or is there no smart way? But the opcode seems to be made out of a couple of fields, because that's pretty normal even on x86, where, well, on x86 also, it's a little crazy, but each opcode is divided into fields, but which fields are in a given opcode depends on the opcode identifier, which is actually called opcode. Anyway, yeah. My apologies. So yeah, n is 4-bit constant. Usually you don't use the term constant, you use the word immediate, but that's fine. And n is basically 8-bit constant, which is 1 byte constant, and n is actually an address. Oh, so no, this is smart. What they did, I said that there would be probably 2 instructions required to fill the address register, but since they just need 12 bits of the address to actually address the whole available 4 kilobytes of memory, then they can just use an opcode, and then 12 bits still fits in it. So that's fine. Then we have X and Y are 4-bit register and identifiers. That means it's just a register index, 4 bits, because we need to address from 0 to F, which is, well, F is 4 bits, right? F is 1111 in binary. Then we have the program counter. The program counter, why do we have the program counter? Is a program counter going to be used here? This is quite weird. I expect PC to be used somewhere in the description and not in the opcode table. Then I, which is the 16-bit register, which again is the address register we did mention a couple of times already. So yeah, so this is the opcodes. I'm not going to go through them now because we will look at them in detail when implementing, and that's about it. And there are some, there's a emulator in browser, and I do hope we can download some ready and working programs so we can test at the end of the stream. So there's a question. I'm trying to implement a remote daemon and log monitor in C++, and to communicate between the server side and the client side. Do you think using OpenSSL is a good choice? Yes, I do think OpenSSL is a good choice, or any other SSL library, which is, I don't know, like boring SSL. You can also, I guess, if you don't want to use OpenSSL, then you can just force the administrator to set up some encrypted tunneling, be it SSH tunnel, or even better, like S tunnel, for example. But OpenSSL seems to be a way better choice than actually, for example, trying to create your own protocol. Especially if this is like, if it's a pet project which only you are going to use and you want to learn cryptography, that's one thing. If this is actually going to be used on production, then do use OpenSSL. Do not try to invent your own protocol, because it's actually a complicated thing to do and it's easy to screw up. So I hope that somewhat answers the question. Now, yeah, I think we know everything, so let's get down to code. I'm actually not going to be using Vim today because I'm testing out Sublime. So yeah, Sublime is going to be my editor of choice for today. Some of you asked on IRC what language will I be using. I will be using C++. So CHIP-8 CC. And here we go. And I will be also coding on Windows, but I will be trying to write portable code, and I will be using the SDL2 library for graphics and other stuff. So SDL2 is your simple direct media layer. I'm pretty used to using SDL version 1. I did create at least like 2 programs for SDL version 2, so I do hope I know something at least. Okay, so I'm not going to download it, or actually, well, because I already have it installed. I think I have it installed. I'm going to check if I have it installed. So, okay. let me actually move my total commander here, but I do need to close quite a lot of windows to do it. Okay, here we go. Here's my total commander, and here are my Mength GCC versions. I am currently using, I think, 64-bit, this one, 64-bit 710 version. So 64 710, yeah. And let's see if I have it installed. So if it's installed, it's in this directory, which is basically has lib, include, and bin. And to check, I just go into the include, and indeed I have SDL2 directory with SDL files here, so I do have it installed. I'm not going to reinstall it. Usually you just download it and you extract it to this directory, because the package you download, for Mength at least, has both lib, include, and bin directories. Now in the bin, I do not have the proper files in bin, so I do need to download it. I do have them in lib probably, though. No. In bin usually you should have the DLLs for it, and I don't have the DLLs, so I'm going to download it. Windows binaries. I just need the binaries. I don't need the development libraries, as I do have them downloaded already. So 64-bit DLL, it's going to be downloaded. Okay, it did download. Now the question is, where did it download to? Oh, okay, here it is. So okay, back to what I downloaded. Is this, and there's just one DLL. I'm going to copy it to the bin directory, so I have it at hand when I need it, and I'm going to copy it also to the project directory, just because when I give it to somebody, to a friend to run, this DLL must be included, will have to be included. So yeah, I'm still going to stay in this include directory for SDL, because I'm probably going to like do some checking here and there, and yeah, that should be fine. Now I might be using like SFML or any other library. It doesn't matter. It's just that I know SDL somewhat, so that's why I'm using it. Okay. Studio. I don't know what I will need, so let's include a studio, and let's start with that. Then I will probably need some arguments, so I wonder how many typos will I be making. Okay. Now, what I expect in the arguments is only one thing, and that one thing is a compiled binary which I'm going to execute on the VM, right? So I do need to check for arguments. This is like, you know, your default boilerplate code. Usage CHIP-8 and then the file name. Okay. And yeah, and then I need to open it. Since is there any, does it say actually that I need to place the program in memory? Probably yes. Most program written begin at location. Okay, so I need to put them in this. I wonder if I need to put them at the 0, or do I need to put them here? Well, I don't know. Okay, that doesn't matter yet. So I'm going to create a class called CHIP-8, which will be, you know, the context basically class for it. And I guess for now I'm going to put the most of the fields public. And I also need stdint.h, which has a nice uint8 declared, which is basically a byte. So yeah, mem and 4096. And I guess I can declare the registers here or as well. So V was what they are using for register, right? Like instead of R, usually you use R, but here they use V. And I know there are 16 registers from 0 to F. And I know there's also a 16-bit register called I, which is annoying because I is usually your, you know, iterator, but okay. I expect some nasty shadowing to happen. Shadowing is if you have like a local variable which is named the same way as some higher level variable, as in, for example, class field or a global variable. Okay, do I need... The stack is part of a memory. Is there a stack pointer? I don't know if there is a stack pointer. I don't know, maybe one of the registers is used as a stack pointer. Let's see if they have like a push or pop operation. Well, I guess we'll find out later. So yeah, this is the context. So what I need to do is I need to actually create a new include, what is it called, memory. Okay, so I don't know, like VM, I'm going to call my object VM and std make unique and CHIP-8. Yeah, okay. So, okay, I created this class now. I don't need a constructor. The constructor has to be there just to basically clean the memory and do some other stuff. So let me create a constructor. And do I do it inline? It's going to be huge probably at some point, so I'm not going to do it inline. I don't need a destructor for all I know now. I will have to initialize obviously SDL and some other stuff, but I will do it later. Okay. So, this is quite... I think I could just do like initialize it here with something like, yeah, like this. Maybe I don't need a constructor after all. Let's try like this and let's see what happens. If it doesn't work, then I like fall back to the constructor. Why the CHIP-8 instance should be like a pointer? Because in the end, I don't know how much memory will I need, because maybe there will be something which needs a lot of memory, so I somewhat expect that my object is going to be large, and therefore I don't want to put it on the stack, which might be limited, so I'm going to put it on heap instead, because on heap I don't worry about it being limited. So it's a good habit to have, and here it's a just question. It doesn't really have to be put on the heap. It could be on the stack, because currently it's like what, like 4 kilobytes. Even on the stack, that's a pretty small amount. Okay, there are two questions. Oh, that was the first one, and the second one. It says that it doesn't have to be in the memory at the second paragraph. Let's go back here. In modern implementation, where the interpreter is running natively outside of 4K space, there is no need for any of the lower memory to be used, but it's common. So it says that about the interpreter. It doesn't say that about the program, and I'm wondering where I should put the program in. I am going to guess that I should put the program here at this address. Yeah. Let's if I'm wrong, then whatever. So I guess maybe no, maybe I'm just going to... Oh, if actually somebody could download an application for CHIP-8 and see what's the size of a file, because if the size of a file is 4 kilobytes, that means that it actually is a RAM image, basically, which we need just to put in RAM, and then it starts at 512, but it also occupies the beginning. Now, if it's actually smaller, if it's always 3.5 kilobyte, that means it actually should be smaller. So yeah, if someone could do that. For now, I'm going to assume that I'm going to put the program at the beginning of memory, and let's see what happens. That isn't, I guess, a best guess, but it's decent, it's acceptable. Okay, so now I'm going to do some like read memory image from file. I'm not going to add from file, const file name, and this method is going to actually, well, I guess the function name is pretty descriptive, right? So first of all, I need to open it, right? Yes, I do prefer the C API. So, okay, CHIP-8 Pong is actually 246 bytes, which is super small. Fabio, could you give me a link to that file? Just looking at the file should tell me something. But given that it's so small, it already tells me that I probably should load the file at 512, because otherwise it would be hard to start at that address. Okay. So yeah, CAPI, then... Actually, if... I'm going to use one trick, but that's going to happen in a second. Read binary. And if f is a null pointer, which means I failed to load the file for some reason, then do this. Now, yeah, okay, I'm going to add fclose here. Otherwise, what I wanted to do is, you know, one of my moderators, KrzaQ, actually writes sometimes about C++, and I think here in this post he actually had a nice way of doing RIAA deleter for the file. Yeah, it's basically this. It's I'm going to copy paste it from his blog, because I mean I really like this approach. So yeah, it's a deleter. What it means is that I can actually create here, instead of writing this, I can write this, which is probably way longer. So, and that's no, that's yeah. I probably want this to be equal. Open. Okay. Yeah. Should be fine now. Now, thanks to this, the code I copied, I actually don't have to care about closing the file, because it will actually run the deleter, which is... okay, one thing I need to change, I guess, in Sublime. Yeah, because it will run actually this operator to delete the file, and since it's going to be deleted... no, I did it wrong. Let's call... that's annoying. Yeah, this is right, correct now. Okay, because it will be run automatically, and it will automatically clean up the variable, which is good. It's the RAIA approach. Like, is it this or is it no? Right. Yeah, this approach. Why is it in Polish? Which basically means that if you don't manually handle deallocating stuff, or actually cleaning up stuff. Okay, so the CHIP language is capable of accessing up to 4 kilobytes of memory from location 00 to blah blah blah. The first 512 bytes are where the original interpreter was located and should not be used by program. This doesn't... Yes, I do remember that. This still doesn't, I guess, answer the... Well, it partly answers the question. I guess no, both clues which you supplied are convinced me that I should actually load the file on, well, on the 512 offset. So okay, reset blah blah blah, then read actually. No. Yes, this is correct now. Mem plus 512, because I'm actually doing pointer arithmetics. How many bytes do I need to read? I need to read 4 kilobytes, but minus the 512. I'm not going to actually calculate it here, because this is more descriptive in my opinion, and I do need the pointer here. So it's going to read, but I guess I'm going to do like return. If this is larger than 0, then that's okay. If it's like 0, then that means that probably something failed, because every returns how many bytes did you read. So let's leave it at that, and here I'm going to actually run it. So if vm read memory image, and from the arguments, if it's not okay, then actually, yeah, like fail to read the program, like fail to read RAM image, whatever. Return to. Yeah, let's see if this actually compiles. I'm probably going to make a makefile though, so here's a makefile. I do need a real tab here. How do I do a real tab? I have no idea how I do a real tab, because I actually turned off making tabs, so makefile might complain. In that case I will actually just run vim on it or something. Yeah, whatever. G++ wall extra, and what is it called? Chip. The source code obviously will appear on my GitHub. CHIP-8, I don't need SDL yet, but I am going to do -l SDL, and now let's see if it compiles. So here we go. I have a proper one set, so make it complains template ID may not appear, and that's a typo I was supposed to remove using, because I am not making an alias here. Yeah, it compiles for some reason. Why did I switch to Sublime? I switched to Sublime just to test it, basically. I mean, I like Vim, but what I don't like about Vim is that the frame buffer is only text and color and cannot do some fancy tricks like Sublime can, or like I even saw some plugins where you could like draw a small icon here for some reason. And I actually have some ideas how to use such features, and in Vim I just cannot do it. So I'm testing from time to time other editors as well, but in the end I always end up falling back to Vim. Let's see how it goes. Okay, I thank you Foxtrot Charlie for supplying me the links. Let's download the stuff. We are, I guess, going to, so first one is Foxtrot, if we could actually give these links out on the channels. Yeah, ROMs, which is exactly what I need. So these are games. Maze. Oh. Okay, let's just download this. No, wait, Bad Logic isn't yeah. Okay, download Furo. Okay. So at least we'll have something to test it on, and it looks like this, if you're wondering. So yeah, I mean, just looking at it, I might guess that this is setting up some registers and then starting to do something. So yeah, okay, let's see. Oh, okay, now I'm starting to get one more thing. Is Studio included? It's here. Okay, so I'm starting to get it. What I misunderstood is that it's actually is that there is only, I thought there is only RAM in this machine, and it's actually not obvious looking at the names here, because we also said ROM. So maybe there is like a ROM chip and there's a RAM chip, and the ROM chip is actually not addressable for some reason. Let's see what we have in the instructions telling about the PC register. Maybe that will answer my question. No, that's just a jump. No, I still don't know. Okay, well, never mind. I'm not going to look at any other implementations yet, but maybe there will be a time where I'm going to actually look at any other implementations. Maybe I shouldn't put the VM program here. Maybe I should declare another array which is for the read-only memory, right? I don't know. That's an option. We'll get to it when we actually, when something doesn't work. It probably won't change too much stuff in code anyway, so I'm not too worried about it. Okay, going back to this. So let's assume I read it. Now I need to actually initialize the VM state. So let's create a new method, which is called like void initialize. The constructor should do it, right? So yeah, but I'm not going to do it. I'm going to call it reset. Like reset the VM. I'm not marking it const because it's actually not const. So what reset is going to do is going to basically, right, I do not have a PC register. I do need the PC register though. So PC. If you're wondering what this weird stuff is and why did it compile, then this is basically kind of a new feature in the newer C++ versions. So yeah, this is a way to zero a variable, and yes, you can do it by like when actually declaring the fields in the class. Okay, going back to the reset, what reset is going to do is going to set the PC at and PC. You know what would answer my riddle is actually disassembling the Pong. That will probably tell me really quickly what are the addresses just by looking at the jumps. Okay, so no, PC is here, and I need PC to be equal to. I'm going to assume it actually starts here. Wait, is there a better specification? Because I realized that Wikipedia isn't probably. This is an extension reference. Wikipedia isn't probably the best reference for it. Technical reference, perfect. And thank you to CowGod for actually having this website. I'm going to give you a link. Okay, memory diagram, memory. So we start, this is the start, reserved for interpreter, then start of blah blah blah, and then program data space. So program data space is yeah, I guess here, but we still don't know it. Did Wikipedia actually like copy paste it? Oh, so this also answers my question whether 8 is up or down. So 8 is actually down, which is reverse than what we have on our keypads, right? Our keypads 8 is up, so yeah, good that I actually looked here. This is okay, this is normal. 0, 0 is usually in that corner. One exception were bitmaps, and if you actually, this is a funny story, right? If you look on BMPs, like the BMP format, then you find out that they're actually like upside down encoded in the file for some reason. And the reason for that is quite funny, because when we're creating the OS/2 operating system, and that was a joint venture between Microsoft and IBM, if I remember correctly, somewhere in the like 80s, then they actually decided for some reason that in mathematics, right, you have usually like 0, 0 here, and then it goes this direction. So therefore, like 0, 0 was actually in this place, and this is the only exception I know, the OS/2 operating system, which is quite funny when you look at it. But yeah, I don't think that was a good idea, especially that, you know, scan lines go always from up to down. Yeah, that had to be hell. Okay, then timer sound, blah blah blah. What I am looking for now, is there any specific reason why I don't use IOStream or FStream? I don't like them. There is no specific reason, I just don't like them. So what I'm looking for now is the reset condition, the reboot condition of the virtual machines, which means what are the start values for the registers, and it has to be in the specification. If you look, for example, in the Intel manuals, there is basically a whole section dedicated to telling you how the processor behaves when you just power on the computer. And it's quite interesting, actually, how the x86 CPU powers on. That's not something I would expect, because it actually powers on in Unreal mode, if I remember correctly. Okay, superchip, interpreters, credits, okay, but reboot values, what are the reboot values? Okay, that's... It's, I guess, another episode of Gunveil reading the documentation. It says nothing. I'm going to assume that all the registers are actually 0 at the beginning, because that's a saint value. I wouldn't assume anything else. I need to implement the timers. Yeah, I don't think there is anything else here, so I'm going to assume that PC starts here and then maybe change some stuff. So did they use, there's a question, did they use negative coordinates? No, they just like, the bottom line was 0, but then like the top line was, for example, like 256 or whatever resolution they had. So, or like 480 or 479 actually. I do have on some of my servers I do have screenshots from OS2, but I don't think I could find them easily. I do know where they are. What you hear, I don't know if you hear it, but if you hear it, that's my backup drive starting. Yes, I do have screenshots from... This is how the installer for OS2 looked like, and this is like one of the final versions of it. And it even had like a nice error looking thingy. So yeah, it was an interesting operating system. It was somewhat compatible with DOS, by the way, so you could run some DOS applications on it, and I think some Windows 3.1 applications on it as well. And it had 3D chess, so yeah. Again, it's like it was a joint venture between IBM and Microsoft, that's why. Okay, so yeah, I'm just going to assume that all the other registers, yeah. I'm shadowing the field, but okay, I don't mind it. All the other registers are basically set to 0. And the reason I am doing this again, apart from doing it when initializing the object is, the object, is because there might be a time where my VM, I don't know, somebody pushes a reset button in the UI, and that actually like has to reset the VM without recreating the object, so I cannot trust that the constructor will actually run again. So this is supposed to be 0. Then the I register, which I'm not shadowing here, I am going to use this I here just because of the stupid naming, is supposed to be 0, I guess, as well. And I'm not going to, I need to add later to do Gunveil add timer initialization. Is it not how you write initialization? I guess it's not. Perfect. So, and the memory probably should be cleared, so let's also clear memory. I'm not going to write a loop to clear the memory. I am going to add though cstdlib, which has the mem set mem0 and size of the mem actually. So yeah, this is going to reset the memory and the registers. I'm going to change the order of it though. So let's do it like this. Okay. And I am playing with the idea of actually adding a constructor which does call reset, but I'm not going to do it now. Reset here manually, perfect. Okay, and now what we can assume is that we have the register values set, we have the image loaded, the program loaded into memory, and therefore we can, I guess we can start implementing the VM itself. I'm not going to create the screen yet, or maybe I should create the screen at this point. Okay, let's create the screen at this point. SDL2 tutorial, my favorite. Blah blah blah. Query. I guess each time I'm creating hello world, perfect. Yeah, this is boilerplate code, so I don't want to spend too much time doing this. So this is SDL2. It doesn't look like SDL2. This looks like, yeah, maybe it is SDL2. Okay, sweet. Yeah, I'm just copying boilerplate code here. I guess I'm going to link to this tutorial as well. It might be useful for somebody. I want to init video. I probably am going to init sound as well. I am going to double check though if So what I'm doing is I'm grepping in the SDL directory for the name of this function, so I can check what's the actual what are the values here. I'm also going to init audio, I think, and I'm probably going to init timer module. I'm not going to init any other, like, I don't, well, oh, this is for compatibility, parachute. So parachute and SDL was actually, in version 1, they handled the exceptions as well, so they caught the exceptions, which was annoying as hell. And yeah, haptic joystick, game controller, nothing for that. Events, I don't know what events is. I'm probably going to initialize it as well. Blah blah blah. If it fails, then yeah, SDL failed. And I'm going to change the return value as well. What else do I need? I need to create a window, but before that I need to destroy cleaning up. Yeah, this is what I need. So cleanup. I probably should do some fancy way of actually not having to call SDL quit manually. And why is this important? This is important because I'm probably going to have a series of ifs, and if any of the ifs fails, then I actually need to do cleanup and then exit. So it would be great to not have to call manually any cleanup functions, so they just call themselves on exit. I could do like use a somewhat similar approach that I used here, but let's see how it goes. Okay, then let's see what they do here. Do they create a window and a renderer? What kind of renderer is it? It's accelerated. Okay, perfect. I was worried that they are creating an OpenGL window here, but this is fine. So again, window, okay, hello world, CHIP-8. The question is, because I don't want it to be at this coordinates, and at this coordinates I have my upper monitor, it would be better if it would actually, there would actually be a hint which says, please make sure that like the window is centered, right? What do we have here? Position centered. Perfect. This is exactly what I need. It seems to be for the X and Y parameters. There is a special flag which is Windows post centered. Basically, when programming in C or C++, it's a good habit to always view the header files. Like, even if you somehow are familiar with a function, do check out these files to be sure that you actually know what you're doing. Okay, now the size of a window. So the size of a window is actually, what's the resolution again? So the resolution, no, this is not what I wanted to see. This is what I wanted to see. The resolution is 64 and 20. Yeah, I'm probably going to make a window which is 10 times the size or 16 times the size. If it would be 16 times the size, it would be still pretty small, wouldn't it? So 16 times 32, it's 512. It's half. Yeah, that should be fine. So let's do it like this. 16 sorry, this is not needed. Here. So 64 times 16 and 32 times 16. Now, the important part here is that this probably should be a constant, so pixel size. Okay, and I guess I should move these to the new line. Okay, this looks good. Const and pixel size equal to 16. Pixels. Pixels and pixels, perfect. This is pretty descriptive. Somewhat. Why ever clean up just before exiting, or at least in this case? This is an excellent question, actually, because usually you don't really have to clean up. Because, well, I mean, when you exit the process, the operating system will close all your file handles, close all your windows, and deallocate all your memory. Why bother, basically? The reason is that I wouldn't have to bother. That's true. That's an excellent comment, actually. I wouldn't have to bother. it's a good habit to have, and this is in this case my only answer, because it does matter in some situations later on, like creating huge applications which run multi-server, that you do have to do proper cleanup just to let other servers know that you're probably like shutting down, or you need to make sure that the database server commits the data which is waiting in a transaction or something like that. So it's a good habit, but nothing more in this case. Okay, obviously this is not okay, because again I'm using this, so yeah. And yeah, and cleanup has to be called here. So I have created the window. Now they ask me to create the renderer, which in this case is, I guess the renderer is going to be passed to some other stuff. So create renderer, blah blah blah, win is my window. I have no idea what these parameters are, therefore I'm going to look for the name of this function in the same directory. And we have this. So what can we read here? Create renderer, this is index and some flags. I have no idea what the index and flags are. Index rendering driver to initialize or -1 to first supporting, that's okay. And flags, I have to see the renderer flags. Let's see what the flags are. And here we are. Software, accelerated, and prevent vsync, and target texture. Oh, they have target texture. That's pretty cool. That's pretty useful for like doing some fancy, I guess, OpenGL stuff. What do I know? What do I need here? It doesn't have to be accelerated for me, but it can be prevent vsync. I actually can allow a vsync to happen. So a vsync is basically, well, I guess all players know it, but when you draw a frame, well, basically when the video card sends a frame to the monitor, to your LCD display, right? It sends it, well, you know, scanline by scanline. I think that's true still. So what happens if you change the frame while it's being sent? So for example, you had a rectangle and you are drawing the rectangle, but half of the frame was already sent to the LCD, and that means that your lower half of the rectangle will appear, but your higher will not. Obviously, we have like 60 frames per second refresh rate, so the effect will disappear later on. But this is it like causes like weird effects on the screen. This is somewhat desired for FPS players, for example, because they say that they can see like at least most of the frame faster, because the system doesn't wait with rendering a new frame to a frame for the vsync, where the vsync is basically information that a new frame is being started to be drawn, I think, or the end, yeah, something like that. It's like synchronization to the vertical synchronization of a frame. In the end, is a signal to tell you that yeah, like a frame is going to be sent, finish your drawing or whatnot. And in our case, we want perfect visual effect, which means we actually want vsync to be there. So that's it. Render, and yeah, this can be here. So if it's null pointer, then destroy the window. Again, like, yeah, if only there was a way to do it properly, which actually does. Means I don't have to write it all the time here. So there are a couple of ways to do it. One of the way is to actually use goto. Goto for cleaning up is, I think, the only reasonable usage of goto in C. Not sure about C++, because again, C++ has other mechanisms to handle it. So yeah. Okay, so this will create my renderer, and I'm also going to copy the cleanup code, blah blah blah. Yeah, these two things. Given that I have this, now I want to give me the frame buffer. I'm just going to like basically use the frame buffer to. But before I get the frame buffer, let's see if it works, if it actually compiles. And I'm not worried about compilation. I'm worried about linking. Get char is a poor man's way to make your application wait for input. So, because if I wouldn't put this get char here, it would basically, you know, just show up the window and close the window. And this is not the effect I want. Okay, running make again, it says blah 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 blah, and correctly so, because I didn't include it. So SDL2, SDL2.h, I think this is the correct header, make, it says that it cannot find it because it's not SDL2, it's just SDL. Perfect. And now it says blah blah blah, mem was not declared, mem was declared here, but I forgot to do this CHIP-8 colon here, which is correct. And it now says blah 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 blah, win main, undefined reference to win main. One of the things in SDL which I do not like is actually that they try to redeclare main. I know that they are trying to do it for probably a good reason, but I don't like it, so I'm going to just type undefined main, and yeah, and this should work. Yeah, it works, so that's fine. Now, I need some water. Is there a question? No. Okay. So it compiles, now let's see if it runs. Oh, it actually has a name, it's not called A. And I need a file, so the file is pong.rom, and yes, it did create a window, and the window is on my top screen, and you cannot see it, and I cannot move it because I'm not handling events. If I would be handling events, then you would see the window as well. So for now, you have to believe me when I say that the window is actually there. Or we could do, let's just remove this for a second and put this here. This should be the position of my my lower monitor. Yeah, it works now. Perfect. And it's not responsive. The window is not responsive because I actually, like, this makes it wait. And it's blocking, which means it's not processing any events. And like, events in Windows are, for example, clicking on the window, having a mouse over a window, moving a window, closing a window. These are all events which the application needs to process. And if I'm blocking the application will not process it, therefore the window will be not responsive. That's why it behaved like that. But that's fine. That's acceptable. Let's continue. I want the frame buffer. How do I get the frame buffer? They probably won't tell me how I get the frame buffer, right? Because they just do render clear, render copy, render... Okay. If they won't tell me, I'm going to find out for myself. Sorry, what's the file called? What I'm looking on? Renderer. Perfect. Lock. Usually there's something like a lock frame buffer, or maybe lock renderer, which should give me lock texture, but this is not the texture, right? Yeah, SDL to get frame buffer surface. Surface is the term they are using for frame buffer. Migration guide. This is exactly what I need, because I actually do remember how to do some stuff on SDL1, but that was you know, ages ago. So yeah, lock. No, the lock frame surface. Okay, create. No, seriously, do I have to create a texture? If your game just wants to get fully rendered frames to the screen. Oh, okay, so this is. Now I get the idea. I think I do have to create a texture. That's quite funny. So, okay, so how do I get a texture from a renderer? Is there a get texture? Get texture mod. Texture blend. I guess I'm going to have to, like, look what we are doing in the tutorial. Drawing a texture, okay. So get texture. How do we create? They create, oh, okay, now I get it, from the surface. But this isn't what I need. So they are loading a BMP image. I don't want to do it, I don't need it. Drawing a texture, what you need to do is... Okay, let me look at the texture again. Sorry, I can, I guess, close this. Texture. STL2 get surface. Get window surface. Yeah, okay. So wait, we have actually something like that in SDL2 as well. Alright, that would be nice. I would love to have a surface for the window. They have something like this, perfect. A surface is, as I said, basically it's a frame buffer. It's basically a structure which defines an array where the array holds the pixel values. So this is exactly what I need. So SDL surface is my window surface. So S surface S surf. I don't know. Let's go surface. And the window, I do have a window, right? So I created a window, and this is probably going to fail horribly because I'm probably missing something. Let's do something like this then. Printed is the best debugging method, except that it isn't, but it did return something. This is not 0, so it didn't fail horribly at least. This is fine. And then I'll have to update the Windows surface. What I expect that this does is that it actually grabs the surface which I modified and puts it on the screen, because changing the things in the array I just described doesn't really put pixels on the screen, right? So yeah, it's obvious right now looking at the clock that we are actually going to continue this next week. So we'll have to do probably this at some point. No, just win. Okay. And it returns int. What doesn't return? It returns 0 or error. Okay, that's fine. So let's change the surface in some meaningful way. Let's see if we can actually draw a pixel there. But I will have to do event event handling before we get there. Yeah, SDL surface is the file which basically defines this, blah blah blah. Yeah, exactly. This is the structure now. Blah blah blah, not interesting. Pixels is what I need. Pixels and pitch is what I need actually. Pitch is the width of the window, but aligned to according to some magic. So it's actually like the length of the scan line. It should be the same as W, which is width of the window, but yeah, let's see. Whatever. Let's print it because I'm quite curious what will it be. So I'm going to print, sorry, is it int? Yeah, it's int, both of them, surface W and surface pitch. And pitch should be, I think, 3 times or 4 times the... Yeah, so it's 4 times the width, which means there are 4 bytes per pixel, which I'm fine with, I guess. Yeah, I'm fine with. It might be quite funny because it doesn't have to always create like a 4 bytes per pixel surface. It might create like 3 bytes per pixel, but I'm going to assume that actually is what is going to happen. So surface, then let's draw a black, no, a red pixel somewhere. So what is it called? Pixels. Perfect. I'm going to change the code layout later on, so this is 8, yeah, pixels, perfect. Where do we change it? So somewhere on the middle of the screen, I don't know, like let's say 512 times, we know the width of the screen, right? It's here, so 512 times the pitch, which is surface pitch, plus, and now the x, so no wait, that's the width and this is the height, so this should be half, like, yeah, times 4, because 4 basically is yeah, 4 is like, again, like how many pixels, how many bytes per pixel are there. Obviously one of the alpha byte is not used in any way. I don't know what's of the mask also. I don't know if the first pixel is the red pixel, is it a blue pixel, or is it the alpha pixel. I'm going to find out soon enough. And I also need to create the event loop. So can I copy some code from the tutorial? That would be useful. Drawing, blah blah blah. No, I'm going to draw in my own way. So Okay, let's go back here. Events, don't put everything in main. Yeah, I know, but handling events, perfect. So yeah, let's do this while quit. Well, for me it's going to be an infinite loop for the time being. I am going to later change it probably. And the processing events is, oh, this is a nice way to do it. Poll for an event, so I'm going to steal the idea. And E is supposed to be some event structure. I think it's actually a union in case of SDL, at least if they didn't change anything. So let's see what event actually is. Again, I'm going to look, like, basically grab through the directory where I have SDL2 headers, and I have this events, which is yeah, this is a union, as I said. SDL event, you cannot see it. SDL event is a union. It's a union of all possible event types, where the first field in each union is basically a type, and then you basically use the proper field of it. Now, I don't care much for most of the events at this point. This is the only event I'm going to care about, which is quit. If it's quit, then I could do a switch here. I don't care too much about changing the tutorial, and I'm just going to do break, and then we go to cleanup. They also quit on some other stuff, and they do redrawing the scene. I'm not going to redraw the scene this way. I'm going to do this, which is, yeah, it should be a poor man's of drawing actually. So let's see if it works. It does compile. Where's my window? I don't see my window. Did it work as well, or did it like instantly quit? Why did it quit? SDF, this works. That's funny. When it polls for an event, oh wait, wait, no, that should be like this. Yeah, now I understand their wisdom of actually doing it this way. So while we don't end, sorry, the end, then do this. I have no idea what's the shortcut for actually moving a block, like adding an indent block. Yeah, and then break, but before you break, make sure that end is equal to true. True, no, sorry, out of typos. Yeah, so this loop exits when it processes all the events in the queue and then can go further. So I guess I'm also going to move it here. At least that's my, I guess I should check it, right? So let's check it, because I think I might be lying here. No, I didn't copy it. Okay, here we are. Events now. If there are any pending events, it returns 1. Yeah, so if all the events were handled correctly, then it just exits the loop, and we can do the update. This is fine. And now, do we have, I don't know if you can see it, but there is a blue pixel here. That means my drawing actually works, which is good. That being said, I did say it's going to be a red pixel, and it's a blue pixel, which means that the mask is actually different. So again, each pixel is described with 4 bytes. The first byte, in this case, as we can plainly see, is going to be the blue byte, then there is the green byte, and then there is the red byte with an alpha unused byte later on. So yeah, so this is basically the description, and this is why I set a value of FF, and a blue pixel has been lit. Now, there are some questions, so let's go through them. I can close it, and it exits, so that means that my event is handled correctly. First, a question: wouldn't writing this VM in Rust provide better performance? I don't see why it would. I mean, I don't know Rust too much, but C++ is a fast language because it contains a lot of word undefined in the specification, and that actually allows the compiler to ignore some edge cases. And ignoring edge cases means not generating code for them. So this is why C++ is actually a fast language, because it doesn't have to check the edge cases, because it trusts the programmer. Sometimes it shouldn't, but it trusts the programmer that the programmer did the right thing and never fallen. The state of the program will never fall in one of the undefined cases, right? I'm not sure about Ruby. If Ruby has like a similar mechanism, then yeah, sure. If Ruby doesn't, then it is probably slower just because it has to handle the edge cases. I did hear really good things about the memory model of Ruby, sorry, not Ruby, Rust. So I don't know how it impacts performance actually. But it's an excellent question. But would need to ask like somebody who knows both languages. Why do I use my favorite for instead of while true? While true is pretty long. You could also write obviously while one, because it's one character shorter and it looks fancy. This is the only reason. There is no difference between them. That being said, in some versions of Visual C++, if you did W4, which was all warnings, it would issue a warning in these two cases that the condition is actually constant. And it worries the compiler that probably you wanted to do something like a real condition there, but it's constant. It will always have the same value. Therefore, it issued a warning for it. And that was the time when I actually switched to doing this, because there is no condition. This being before. But you can use any. It's like personal preference, basically. I just prefer the for. Should we move event handling to a thread? This is actually an excellent question. So my take on it is leave the event handling here, because this is the main thread, and there are some events that only go to the main thread, at least in Windows. I don't know how SDL handles it. That being said, let's move the VM to a separate thread, because why not? So all the execution will be in the separate thread. Is Windows 10 operating system like a secure operating system? It's way better than previous Windows due to changes. Microsoft does actually quite a lot of good tweaks between large versions of Windows, and that started like with adding dep to XP. Then Vista had quite a lot of changes all around, including like a proper ASLR. Then Windows 7 had some improvements, like for example driver signing on 64-bit, which is bypassable, but whatever. And then like Windows 8 had also some kernel changes. It allowed to create a sandbox where the Win32k syscalls were not allowed. And then Windows 10 also had some improvements all around actually. So it's a more secure operating system than previous Windows versions. Now, is it a secure operating system? No, I mean, there is no secure operating system on the market which is usable. I'm sorry. Like, if it's a large operating system, it will be full of bugs, or people will not use it. Like, for example, OpenBSD has a really good security level, and that being said, it's not an user space operating system for desktops, for laptops, which means that they avoided a lot of problems that way. Yeah, but it also is missing some features, and when you implement features, new bugs appear, and some bugs might be security bugs. Therefore, we have problems in all the operating system. That being said, Windows 10 is pretty decent actually. I mean, yeah, these are not the times of Windows XP without service pack, when like the time between you connecting your computer to the like wall socket, the Ethernet cable, or the modem, and going online and being infected with like a exploit, just randomly scanning the internet and hitting your PC and infecting it, was, I don't know, 5 minutes, right? But these are not these times, and Windows 10 is way more decent and way more secure. Okay, sweet. Let's what was this? We like jumped into a different topic. There are a couple of fun questions here. This update Windows service shouldn't be done all the time, but that doesn't matter. What matters now is how to create a thread. There are two ways that I could create a thread here. I could create a thread using C++, I mean std thread, right? That's one way. The other way is actually maybe SDL now has a way to create threads. I don't know. I'm going to look for the word thread in here, because SDL is supposed to be this like portable library which you can compile on Linux, on Windows, and so on, and it supplies all the basic mechanisms which you have to use to create like a game, right? Does it have a thread? It does have an SDL thread header, which means you probably have a thread. We have threads probably. How do you create a thread? Create. Okay, so I'm going to use SDL to create a thread. Or am I? What is this supposed to be? This is quite weird. Oh, they actually have a nice macro here, which, yeah, I mean, both C++ and this is like pretty similar in usage. Though here we have to actually create a function out of their specification, which is none of these. What's a thread function VM? Sorry, the thread function fn here. Yeah. Okay, let's. I didn't ever use SDL threads, so let's use SDL threads just because I sometimes want to do a hard fail as well. Okay, SDL init, create window, create renderer, and this is probably the moment when this is the moment where I want to create the thread. So create the so this is the thread function. Sorry, wrong copy paste. Okay, then like VM thread, or maybe no, this is fine. VM thread func. So this is the function, then the name and the data. Oh, the name of a thread. So some threads can have names in some threading systems, and this is quite useful when debugging something and getting, a call stack, and you see the thread ID, but you don't know like which thread is it, like on a logical sense, right? And if you can name the threads, then you get the name of a thread next to it, and you can actually say, oh, this is like, I don't know, the renderer thread or like the event thread, and it's quite useful actually. So I'm going to call it the VM thread because this is the VM thread. And then the data which is basically a structure passed to the thread. In my case, it's going to be, obviously it's going to be the VM, yeah, like, but this thread is not going to own it, this object, therefore I'm just passing the thread, I'm not passing the unique pointer. So I'm assuming that the thread is not going to deallocate this object at any time. Yet we are creating here a dependency, obviously, like that when we exit the program, and we exit this function actually, exactly at this point the object is going to be destroyed, and at that time the thread has to be dead already. It's probably going to die here if SDL actually keeps a list of a thread. If it doesn't, then it might like crash the program in some cases. Perfect. There is an SDL. Yeah. We need a handle. We need a handle just to, for example, wait for the thread. There's probably some join or wait. How does it called? Join? Wait. Wait. Typing is hard. Wait thread. Perfect. Wait thread sounds good. Status. What is the status supposed to be? We can detach a thread, but no, we need to wait for a thread. Okay. Status. Oh, the status is probably the return value. Can I put it a null here? Status is not null, wait. If status, return code. Okay, so I can put it null, which is perfect. So here, just before destroying everything, I need to make sure that the thread actually exited. So th is the handle of the thread, and then the status, which is going to be a null pointer, obviously. And I guess after this function, it's guaranteed that the thread has already exited because this is actually blocking. So yeah, so this is fine. I do need a way to communicate to the thread that, hey, it's time to actually exit. Yeah, okay, so now I have this, now I need to actually create the thread function, right? Which is, it's going to be a, yeah, if I would be using C++ threads, I wouldn't have to be doing what I am doing now. And what I'm doing now is I'm actually going to, what does this function take, by the way? No. Thread function. Here we go, adjust data, okay. The data is actually an object. We know that it's an object, but we still have to do this. We have to, why didn't it? Okay. Sometimes when my editor puts a bracket in the wrong place, I get a little paranoid because I think that, oh, I must have forgotten to close some bracket. And it's a good hint for the programmer, but you forgot something somewhere. Here I think it's fine. It's just like, because I retested it, where does it put the bracket, and it puts the bracket in the correct position, so it's fine. Okay, but yeah, it's a good hint actually from the editor that something is wrong. Now, what I need to do here, I need to create, like, in the class some method which is going to actually handle the thread. For example, main loop doesn't make too much sense. Main loop. Run, maybe. I don't know. I don't have a good idea. Main loop it is. Can be run in a separate thread. Perfect. Now, therefore, first of all, the VM is... It's not what we think it is, because CHIP-8, we need to actually create a pointer to it. We need to cast it. We know it's this kind of a pointer, but given that we are using void to pass it, because I think SDL is actually like a C library, it's not a C++ library, so it doesn't use any templates and so on, so we do have to do it in this way. Okay, and now return 0 at the end. We don't care about the return value, and we want to call main loop here. Yeah. Perfect. Now we can just implement the main loop here, and that's fine. What I would like it to do is actually to figure a way to shut down the thread as well. Usually you use events for it, or some other objects like global variables which are atomic and synchronized. Do we have events here? What's that? There's a different name for in signal. Yeah, no, not signal. Come on, what do we have here? Mutex at least? There's an SDL mutex and SDL atomic. This is cool. SDL atomic. I do like SDL atomic. An atomic variable is a variable which has yeah. How does it work? So yeah, try lock, spin lock. No. So an atomic variable is a variable which is basically guaranteed that a thread writing to the variable will write the whole variable in one go, and other threads will wait until this thread is finished writing the variable. A non-variable, a non-atomic variable, on the other hand, is a variable which can be like written just halfway, and then the other thread says, oh, I need to read it, and reads the variable which is only halfway overwritten. Now, on x86 we are guaranteed that, for example, integers, if we are aligned to the natural boundary of 4 bytes, are atomic and by design. That being said, from the C++ perspective, there's another thing, as in the C++ compiler does some reasoning about the code based on, for example, it doesn't assume, like, at least the older versions assumed that if you have a function and that function always reads a variable but never writes to the variable, then that variable will probably not change, right? Because why would it? You never write to the variable. If it's a global variable, then another thread could change it, right? So this reasoning is not correct. And there is basically there are ways to tell the compiler like, hey, I'm pretty sure that this variable can change in a ways that you do not expect it to change. And the volatile, for example, keyword was used to it. And yeah, so I am hoping that they actually have implemented such variables here, so I can do it using just their functions. There are some barriers. I don't need barriers actually. Barriers is a different thing. Barriers are related to reordering. If you have like two global variables and you write to the first one and then write to the second one, and then you have another thread which reads from the first one and reads from the second one, on x86 the second thread could actually, even if you have this written in the code, the compiler may generate the code, or the processor might optimize the code execution in such a way that the order of reading changes. On some other architectures, actually the write order might also change, and you need a barrier basically to tell a memory barrier to tell the CPU, okay, like at this point you have to be sure that all the memory writes are committed, or at this point you have to be sure that all the reads are done. Yeah. Otherwise, basically the CPU will try to do some funky optimizations by reordering memories. Blah blah blah. This is quite important what I said, and it's called atomic, and I guess they have atomic set and atomic get. Which, okay, I'm going to use it just for the sake of it. I'm going to make an atomic vend, which is supposed to tell it to exit. There are some questions. What do I think about Google C++ style guide? Well, I use it daily, so I'm quite used to it. I don't mind. I know that some people say that, oh, but it like doesn't allow you to use these features or the other feature. I think it's fine. I also like the fact that it actually limits the amount of, for example, pointer arithmetic, where pointer arithmetic is not a thing you should be using in modern C++, right? So yeah, I guess like this is somewhat acceptable, but not really. There are like more safer way to do it. So I think it's fine. Shouldn't use share pointer instead of unique pointer while sharing VM unique pointer with a thread. Why do I not use a share pointer? I could use a share pointer here. Share pointers basically, if I remember correctly, have reference counting, which means that when the last block of code which owns a shared pointer to a given object exits, then the reference counter goes to 0 and then it's deallocated. I could use it. In my approach, I basically assume that the thread is just not going to do any deallocating, so the function running in the thread doesn't own the object. It's another approach to basically the same problem. I mean, one which I prefer. You could use any. In my approach, you actually have to do some manual tracing of who is the owner of what object, but I guess I usually, when I'm writing the code, I try to keep it documented and clear that something like some object is an owner of another object, or is it not an owner of another object. A problem with shared pointer is that you have no guarantees where is it going to be destroyed. And there are cases, not always, but there are cases where that might be confusing or might lead to bugs. So here I actually, by using this approach, I do guarantee where the object is going to be destroyed. Yeah, so I hope that answers the question. Cool. So yeah, this is the end, which means that, okay, and this is, I need to implement this function. We are probably going to finish in around 5 minutes, and next time, I guess like all the juicy stuff which are implementing the actual opcodes is going to happen next week, but I guess we had some structure code to write before we can get there. So main loop, but main loop is actually in this namespace. Well, that's not really a namespace, that's a class. And it doesn't take any parameters, because why would it? It has, well, obviously the like implicit parameter of the object, which is, you know, this, which, if you actually look in the assembly code, that's not an implicit parameter at all. It's just there as like a usual parameter or in some special register, but it is there. So while, no, let's do it in a different way. Let's do it like this. And now there was some get atomic. And it returns, yeah, perfect. Yeah, get the value of the end. So if I get it, yeah, so what I'm counting on by using atomics here, the real thing I'm counting on here is that they internally convince the compiler to always get this value and don't do any funky optimization, assuming that this value will never change and just not getting it at all. If this value is equal to 1, then we exit, we break. That's it, done. Okay, now here, no, on reset, here I guess I'm going to also, no, wrong. It could be like this, but this, due to writing this one becomes a magic value, and I would prefer to say like not 0. Just because. It's like I don't think that makes a small difference, like makes me a little more happy about it. And then on reset, I'm going to change it. No, I'm not going to change it actually on reset, so I'm going to leave it as is. However, here, before this, I need to make sure that the end is actually written to, and what I write there, using the atomic obviously, is some non-zero value. 1 is a good non-zero value. And like, yeah, I don't know, I could write a comment here like, let the other thread know that we are finishing, but I am not going to do it. Actually, when writing production code, I wouldn't do this here. Instead, this would be a part of the class itself, and the class would spawn a thread. The problem is here that I don't want to include too many SDL dependencies in the class, because I don't want the class to be tied to SDL. That being said, I am using SDL atomics there anyway, so it gets funny how to design the code, so it's actually the class is testable without using the SDL code. Sweet. Does it work? Do I know if it works? So this is an infinite loop, which will basically, sorry, where is it? Yeah, this is an infinite loop, and I do not want an infinite loop here. I do want it to sleep. Can SDL actually, does it provide me with a sleep function? It probably won't, because, or delay maybe it's called. No, there is a delay, perfect. So yeah, delay like 1 millisecond. This is enough to, or like, yeah, 1 millisecond should be enough to not fry my CPU. Cool. Okay, let's see if it works. So it's running, the window is responsive, as you can see. The pixel is here, I don't know if you can see it, but do believe me, it is here. I am going to, I guess, light a white pixel there. I'm going to press, like, close the window. It exited. The fact that it exited means that this function did stop locking, and it means that, well, the thread created and then the thread exited, so this is fine. We can, I guess, double check if the thread was really spawned, because the same behavior we'll get if the thread wouldn't spawn, right? So I'm going to write ASDF there, and I'm going to do this again. ASDF, as we can see, is here, so that's fine. I guess there are a couple of questions, but we are finishing, so I will get to them in a second. If you have any questions, it's a good time to actually ask them. This thing, remove to allow the VM to run at full speed. And I am actually going to remove it later on, because I do believe that the VM has to do some locking. It has some blocking operations anyway, so But it can run at 100% CPU, why not? It's just one core and I have a lot of cores, so I don't mind. So I guess I'm going to finish it for now today here at this point. Next live stream I'm going to here, exactly in this function, implement the opcodes. And before I get there, I guess I'm going to answer the question is my thinking about where the image should be placed in memory and what the beginning arguments like for PC are were correct. So yeah, so this is it. Now let's go through the questions. What do I think about the new IDA, or have I switched to Radari? I didn't test the IDA 7.0 yet. I did hear good opinions about it as like some things being fixed which were like somewhat annoying in the past, so I have high hopes for it. I didn't switch to Radari, I didn't learn Radari 2 yet. It is on my list, as you know, for the last year, but I didn't get to it yet. Did I make a mistake with PC? Blah 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 blah. Sorry, where is my reset function? Here it is. Yeah, obviously this is a typo. Thank you very much, Etop, for saying. Sorry, you don't see it. Yeah, here. This is a typo. It was OX 512. It should be 512 or OX 200. So my bad. Thank you for telling me. You are correct, Etop. Okay, and I guess the last question was something I already answered, so I can remove it as well. Are there any more questions? If not, I guess we can wrap it up. As you know, I think Mormos is going to start streaming in 20 minutes. So yeah, that's it for today. Yeah, I didn't see any questions. So thank you to Foxtrot Charlie for actually being my moderator today. And I'm going to upload this code to GitHub as soon as possible, though it doesn't do anything yet. So see you next week, and next week we're going to continue the implementation. There's a mission today. Good luck with the mission. And as I did mention, I will not show mission solutions during the live stream. I am going to make videos and publish them on my channel about the solutions. Thanks to it, we have more time on the live stream. Are you going to implement memory management for the VM? No, as in there is no memory management for the VM needed. We did allocate one array for the 4 kilobytes of RAM, and that's as far as it gets. If the application running inside the VM wants any memory management, then that's user space or application space problem, which means the application has to implement it. And I don't think it's needed for 4 kilobytes too much. Anyway. Cool. Thank you. Good night. Have fun. Happy hacking. And see you next week. I'm leaving you with a mission and some music. Bye bye.